Okay, today we're going to start learning about Newton's method. What Newton's method does is that it uses tangent lines to approximate the graph of the function near its x-intercepts. If you look at page 229 of your textbook at figure 3.6, as well as page 230, example 1, those are some good examples of what Newton's method looks like. I will do my best to explain to you Newton's method through this picture. What Newton's method says that I should be able to approximate this zero through the use of tangent lines. So what I'm going to do is just pick some value on this graph. Somewhere close to the c value is what we're always going to do, and I'm calling it c value because there's going to be a lot of x's, and really what I'm doing is I'm trying to figure out where it crosses the x-axis here. So I just went ahead and labeled this first point as x sub 1. So it would be x sub 1 comma y sub 1, and I went ahead and said that's the function, or f of x sub 1. So what I'm going to do is I'm going to draw a tangent line to the curve here as best I can. And what I'm going to do is I'm going to write the equation of that tangent line to the curve. The equation of that tangent line to the curve in point slope form would be y minus f of x sub 1, that's the y value, and that we write equals m. Well, the slope would be f prime of x sub 1, and then x minus the x value, which would be x sub 1. What that allows me to do is I'm going to be able to approximate a new value of x, and we'll call this x sub 2. Well, in order to find this x sub 2 value, that's really where the y is equal to 0. So what I would do is I would substitute 0 in for y, and I would solve this equation for this x value, which would be my x sub 2 in this problem down here. So this falls out. What I would do to both sides probably is just divide by f prime of x sub 1. So I'll divide both sides by f prime of x sub 1. That gives me negative f of x sub 1 over f prime of x sub 1. And this equals x minus x sub 1. What I would do now, I don't really need these parentheses, so I'm going to get rid of those, is I want to solve for this x value. So I would add x sub 1 to both sides. And when I did that, I'd end up with x sub 1 minus f of x sub 1 all over f of f prime x sub 1. And this equals that new x value, which I have called x sub 2. Now, what does that do? Well, what it does is give me a new starting point, and then I have to draw another tangent line to the curve. And notice what happens this time is that my new x value has now gotten closer and closer to c. So basically what we're doing is going back and forth between two values, okay, to come up with this c, this x-intercept. So it's just a way of finding x-intercepts without knowing a lot of information, or if it's an x-intercept that's hard to solve for. We're going to fill out a table to do that, but I wanted to give you kind of an idea of where this was coming about rather than just doing this process. It is a process, but hopefully this helps explain the process to you. After you would do this, you would just keep redoing this, and you draw another tangent line to the curve every time you get closer and closer to the c value.